All right, Applied Math. We are continuing our look at probability today. In class yesterday, we just looked at simple probability and we looked at Venn diagrams. Today, we're going to take a look at two-way tables, and we're also going to look at conditional probability. So just adding a couple new wrinkles to this. So this is an example of a two-way table. So on this table, we've got some random factory, and they're keeping track of what each worker at the factory drives to work each day. So a two-way table is a really nice way to represent something that has two variables. So our variables here are the shift. Do they work the morning shift, the day shift, or are they working overnight? And the other variable is the type of vehicle they drive. So we've got a bunch of different types of vehicles here. So notice one variable goes down, the other variable goes across, and it doesn't really matter which is which. Typically you'll see the variable with more different types going across just because the table looks nicer that way, but honestly it doesn't matter. So we can use this to pick out any values we want, like if we want to know how many day shift workers drive a four-door sedan, we can look at 20, well, there's 25 of them. If we want to look at how many night shift workers drive a pickup truck, we just go night, pickup truck, and see that there's 11 of them. And then the other nice thing about these tables is that the totals across the bottom should match. So if we take and add all of these totals across the bottom, we get 246. If we add up all of these totals down this last column, we also get 246. So all of our numbers match up. And we can use this to calculate probability. So go ahead and try to figure this out here. What is the probability that a randomly selected worker drives an SUV? Okay, to do this, we need to look at how many SUVs are being driven, which is 91, and how many total workers we have, which is 246. So 91 out of 246 drive SUVs. We divide that. We're going to have to do some rounding, but no big deal. So the probability is 0.37, or about 37% of our total workers are driving SUVs. So that's how you would calculate simple probability using one of these two-way tables. Where they really shine, though, is when we look at something called conditional probability. So conditional probability means that we have more information, and having more information changes the probability of an event occurring. For those of you that picked the Monty Hall project in whatever chapter that was, I don't remember. It may have been chapter 1, but you picked the Monty Hall project, so there was the 3 doors, and there's a car behind one of the doors, and the host, Monty Hall, always shows you a goat. And the Monty Hall problem asks, should you switch the door? You choose a door, and then you get the opportunity to switch after you have more information. And the answer was yes. You always switch doors because the probability has changed now that you have more information. So this works the same way with these two-way tables. What is the probability that a random worker drives a motorcycle given that they work the night shift? So our probabilities have changed. We're not looking at 11 out of 246 anymore. We're looking at just the night shift. We have narrowed our search to this row right here. So go ahead and see if you can figure out what is the probability that a random worker drives a motorcycle if it is given that they are a night shift worker. Okay, since we are only looking at this row right here, there are 5 motorcycles out of 59 workers total. So that probability is about 0.08 or 8%. So we're going to put all of this together with the Venn diagrams and the two-way tables, and we'll work a couple days on that. So this is a real short video, but if you've got any questions on anything I said, make sure you ask them, and I will see you in class.